Okay, so now I'm going to talk a bit about the environmental monitoring programme that's been happening at the observatory. So Andres and Paul showed you the very small changes in temperature and flow that we can see when we do heat changes. But really, I'm going to talk very briefly about a huge amount of work done by a lot of my colleagues around what the baseline of the environment was, the water environment, the gas environment, and the geomechanical type environment. And then just do a little bit of comparison with what we see when we start this geothermal experimentation. And why is that important? Well, yesterday we had a lot of talk about regulation, and clearly all these things are important from a regulatory perspective. But on this slide, I've highlighted a different aspect, which is also the sort of social acceptability. In these old coalfield areas, commonly the shallow land use has been quite complicated. People are concerned about subsidence. So there is a possibility of people being concerned, and we've certainly heard that when we've done stakeholder engagement. You know, they might panic about things, they might protest about things if we don't really understand that baseline environment about how things were before we started doing geothermal work. So the point of, or one of the points from all this work is around understanding that, measuring it, getting that evidence base about what was there before and what was changing anyway in the environment, and then what was changing now. And also another comment that was made yesterday about what's fit for purpose monitoring. What do we really need to do? Clearly at this site, on this diagram, you can see on the picture, we've done loads of monitoring. We've done far more monitoring than you would do for a commercial scheme, and there are a lot more sensors. But understanding which of those are important, you need to measure more to get that answer about which one is important. So I'm just going to show 3 examples of the baseline monitoring. The first one is on groundwater data. So the picture on your left-hand side, the bottom graph with the green and the orange curves, this is groundwater data monitored over a whole year. It was the first year that the groundwater loggers were in some boreholes in the mine workings. And basically the main feature of these is you can see overall there's a big curve. That's a seasonal curve. In the winter, the water levels are higher. In the summer, they're lower. But within that, you can see lots of different peaks. As Andres showed, you know, when there's a lot of rainfall or the pressure changes, then we see difference in the water pressure in the boreholes. But then if we zoom in, that small image with the green line, what we see is daily fluctuations or more than daily fluctuations, which relate to earth tides in the borehole. So there's a really complex baseline in that groundwater data. And we need to understand that before we start doing the geothermal work, so that people don't just look at the data and say, it's changing when you're doing geothermal work. And it is changing when we do geothermal work. We can see that on the right-hand side, which is an image. You can see the yellow, the orange and the blue lines are the water levels measured by the hydrogeological loggers in some observation boreholes. And so we're seeing those regular earth tide type variations, daily variations, and highs and lows in those water levels. But there are also 2 peaks that you can see that stand out. One of them was an abstraction experiment, and one of them was a reinjection experiment. And their signature is really different to that from the baseline. So it just gives that example of why it's important to measure a baseline and to understand the response of to the geothermal experimentation. The second example I've got is around ground or soil gas. Again, this is one of the areas that, for regulatory purposes, it's really important to understand. And so at the observatory, before we started doing construction, there were various surveys of the soil gas, which is the picture you can see on the left-hand side is like a survey grid where different types of gas were measured in the soil. We've also got soil gas probes at some places. So the graph on the right is an example of a soil gas probe data. And again, what you can see is a year's worth of data, and you can see a big curve. The kind of line in the middle, the orangey one, is a temperature. And then the grey and the orange at the top of the bottom are oxygen and CO2. And we've also done isotopic analysis and things on some of these data. And we've now got some scanning lasers on site for near-surface air quality monitoring of CO2 and methane. And taken together, all this data on the kind of ground gas, our summary at the moment is we don't see any evidence of mine gas migration. Using some of the isotopic data, for example, you can look at the processes that form the gas, as Angela explained earlier today. We think those variations that you can see are to do with natural photosynthetic and bacterial oxidation processes, which vary by day and by season. And then the final example is about ground motion. So again, in mining areas, either uplift or subsidence related to mining is important. And so some of the monitoring that are at this observatory, so if you start on the picture, which is actually on the bottom right, is a little box called an active reflector, which together with another thing called a passive reflector has increased the precision of the INSAR data, which is how we measure the ground motion using satellite data really, really precisely. The image on the bottom left, you can see those two little reflectors in the area of the observatory at Cunningar Loop. So it's increased the accuracy, and the top left-hand image is how much the ground has gone up or down in a much wider area of Glasgow than the site we're looking at the moment. But the general picture is over a regional scale, the ground isn't going up or down very much in the area. And again, that's really important for us to know. There are some local areas where there is a very gradual decrease in the ground level, but that seems to be due to a widespread area of compressible soils as opposed to mine-related ground motions. So just in this very quick summary about the environmental monitoring, you can see that we've got lots of different types of monitoring in place for before, during, and after geothermal operations. We can really see in some data sets, in some of the water data sets, we can really see seasonal and daily variations. But what we can't see is any evidence of subsurface to surface pathways. We can see evidence of lots of small-scale pressure changes related to pumping, but we understand those processes. And there's also a number of parameters that are really stable before and during the commissioning works of the geothermal operation, so things like the ground gas, the ground stability, and so on. So at the moment, we don't have any red flags for environmental impacts in relation to the geothermal experimentation that people can come and do at the site. And in terms of fit-for-purpose monitoring, I would personally, my choice of fit-for-purpose monitoring for this work that we've been doing is the real key thing is the hydrogeological loggers that we have downhole have been super valuable amongst all the different techniques that we've used for the relative cost that they are. So I shall stop there.